Picture this: a football field-sized marvel, humanity's first home in space, orbiting Earth 16 times a day. The International Space Station, the ISS, has been our window to the stars for over 25 years, but soon that window could close. By 2030 it might plunge into the Pacific Ocean, gone forever. Why? Is it aging hardware, budget cuts, or the dawn of a bold new era? Today we uncover the ISS's epic legacy, its game-changing discoveries, and what comes next. Buckle up, this is the future explained. Let's rewind to 1998. The first piece of the ISS, a Russian module called Zarya, blasted into orbit. Over 2 decades, the US, Russia, Canada, Japan and Europe built a 109-metre-long, 420-ton laboratory zipping around Earth at 28,000 kilometres per hour. That's a full lap every 90 minutes, 16 sunrises and 16 sunsets every day. But the ISS isn't just big, it's a symbol of what we can achieve when nations unite. It's our first permanent foothold in space, a testing ground for the Moon, Mars and beyond. So what has the ISS actually done for us? Spoiler: it's transformed life on Earth and prepped us for deep space. In microgravity, our bodies go haywire. Muscles shrink, bones weaken, and even our genes act strangely. Take astronaut Scott Kelly. He spent 340 days on the ISS while his twin, Mark, stayed on Earth. Scientists found hundreds of genes in Scott behaving differently. Most returned to normal, but some epigenetic changes lingered. This data is crucial for planning Mars missions. Then there's biology beyond humans. In space, protein crystals grow perfectly, unlike on Earth. These have led to advanced drugs for Parkinson's and cancer. And in 2015, astronauts ate the first space-grown lettuce, a test run for farming on the Moon. But it's not just biology. Fire in microgravity burns as a slow spherical glow, helping engineers design safer engines. Liquids form perfect floating spheres, rewriting fluid dynamics for better diagnostics and printers. And 3D printers on the ISS, they've churned out tools, brackets, even wrenches since 2014, paving the way for building satellites or even organs in orbit. Here's the kicker. The ISS, 400 kilometres above us, has reshaped life down here. Its research gave us cleaner water systems, precision-targeted drugs, lighter building materials and better batteries. It even helped us understand how life evolves. Sure, the ISS cost $150 billion to build and billions more to maintain. Critics say that money could have solved problems on Earth, but the counterpoint? Its discoveries have saved lives, sparked industries and paid dividends we're still counting. The ISS isn't just a lab, it's a gift shop for humanity. The ISS didn't just change science, it birthed an industry. NASA's contracts to deliver cargo to the ISS gave SpaceX the boost to develop Falcon 9 and Dragon. Without the ISS, SpaceX might not be the giant it is today. Blue Origin, Axiom, Sierra Space, they all owe a nod to the station's role in proving private spaceflight works. Ironically, SpaceX is now building the vehicle to deorbit the ISS, guiding it to a safe splashdown in the Pacific's Point Nemo. Poetic, right? The ISS created the conditions for its own exit and for a new space age. So, why end this masterpiece? It's not failure, it's success. The ISS is aging. Modules from the early 2000s are wearing out, and maintenance costs NASA $3 to $4 billion a year. NASA plans to retire it by 2030, deorbiting it in 2031. But there's drama. Some reports suggest earlier US administrations considered reducing ISS funding, aligning with this timeline, but raising eyebrows. Meanwhile, Russia plans to exit by 2028 to build its own station, and China, never part of the ISS, runs its Tiangong station. Geopolitics could push retirement earlier, or delay it if partners like Europe and Japan keep investing. The clock's ticking. Will the ISS outlast these challenges, or is its dive into history inevitable? Don't mourn the ISS, celebrate what's next. Private space stations are already in the works, ready to take the baton by 2028. Axiom Station will start as ISS modules before becoming independent. Orbital Reef, backed by Blue Origin, promises inflatable habitats. Starlab and Vast Haven stations aim to be labs, factories, even hotels. These stations will specialise: growing medicines, printing spacecraft, hosting tourists, training Mars crews. But it's not a sure bet. Funding, safety and market demand are hurdles. If they're not ready by 2030, a gap could stall research. NASA's betting big on companies like Axiom to bridge it. Here's the big picture. The ISS taught us how to live in space. Now we're ready to dream bigger. By 2040, we could see 25 private platforms in orbit, labs, resorts, factories, though that's an optimistic guess. Beyond Earth, the Lunar Gateway Station and early Martian outposts are already in NASA's sights, building on the ISS's lessons. The ISS proved space isn't the limit, it's the starting line. Its final dive won't be an end, but a launchpad for humanity's next chapter. Explorers. The ISS showed us what's possible when we reach for the stars. What should the next stations do? Build medicines, welcome tourists, or prep for Mars? Drop your ideas in the comments, hit that subscribe button, and stay future ready.